Welcome aboard to JTEC's Marine Class Lab. I'm Craig P. Bottoms, the JTEC Marine instructor. My credentials are, I started the inception of MMI Marine program, was there 23 years. I was also involved with their dealer training program, which was Mercury, Volvo, Honda, various other manufacturers. And I had a 5-year run at Wyotech, formerly AMI. Also started up a Warner Christian University class at Lake Wells. So I am here currently as a JTEC Yamaha instructor, and I'm going to show you a task on inspection of a cylinder head. This is a B series, or it could be N line, but it's a Yamaha late model head. It is made of aluminum. It is a 4-valve head. As you can see, the larger valves are intake, the smaller valves are exhaust. You'll have a 4-cylinder, and some folks would refer to that as inline. And if it was on a V configuration, there'd be one on one starboard bank, one on the port bank. As you can see, it's highly precision machined. And our goal is to check to see if it's straight or flat. All right. In order to do that, you would need a precision straight edge. This particular straight edge can measure down to 0.010 of an inch. 0.010 of an inch is not physically seen with the naked eye, so it's very difficult. But that's the precision of this straight edge. In reference to this cylinder, what happens in the field is the engine will get hot. Obviously, if you have it down to this stage, you're into a rebuild. All right. So what happens when it gets hot due to a cooling system problem, like the water pump, when you unbolt it, you can see where all the fasteners would hold to torque the head down. And when you unbolt it, it turns into what I call a banana. But that's exaggerated. It would be warped. All right. And the technician, hopefully trained from JTEC, would be able to check it with a precision straight edge. And it's pretty simply done. It's called a X pattern. You put it across the machine surfaced area and a crisscross pattern. And then you would take the feeler gauge. You could use the metric or you could use SAE, either one. Some people prefer the kick in the bottom of it or the boot type bent, or some people prefer the straight. The spec in the manual would be 0.002 of an inch. Okay, the smaller, preferably 1,000ths, would be superior over that spec. Roughly 0.002 of an inch is the thickness of a piece of paper. So you would look for that particular feeler gauge. The next thing most mechanics would do before the feeler gauge would they would look down to see if they could see any light. The light between the straight edge and the cylinder head. So that obviously would tell you if you could see light where you could drive a truck through it. And I could see on the other side of this opposing head, you might not even need the feeler gauge. The next step, technically, would take the feeler gauge to see at preferably 1,000ths, which is better than the manual, and take it to see if it will go into the straight edge between the cylinder head surface. Obviously, this one's flat, straight, perfect, and then you would flip it to the X pattern or cross pattern and do the same. Look for light, and then try the feeler gauge again. Again, preferably at 1,000ths versus 2,000ths because it's a tighter spec. This particular straight edge, because it's precision, they're expensive, would need to be oiled down and cleaned and put in a felt liner. Because if the tool depends on the quality of the job you get here. So this particular cylinder head, which is a double overhead cam, 4-valve head from Yamaha, is past that particular test. But I want to show you a couple other avenues on it. These are your exhaust ports. They're oval. These are your water passageways. Again, it's a 4-cylinder inline. So you'll have exhaust port, water passageway for each cylinder. And then you can see the water passageways internally around each combustion chamber or cylinder, and it continues to go through the head. Obviously there'll be a head gasket laid down, manufacturer OEM head gasket, and then it would be bolted up, retorqued. For the future, we will be checking the valves and the valve faces and the condition of those and how well they seal. That's the integrity of this engine. All right, folks, on the other areas of this head to inspect would be leading into our next video, but I'd like to give you a little intro to the next one. We would flip the head over, and you can see these are the cams. It's a double overhead cam. One's going to be the intake cam, one's going to be the exhaust cam. You have, these are your intake, these are your lobes, and they're going to be measured in duration and width, which we're going to lead into the next video. This is a shim bucket type actuator. There'll be a spring involved with that, but the actual valve adjustment will be included into that also, because that's part of the maintenance on this particular head. This head has a lot of zinc anodes under it, which you would be performing on Yamaha's PDI, 100-hour maintenance, 50-hour maintenances, and that's what would be these items here. You can see them here, obviously for saltwater corrosion. You can also see them here. And these holes here is where the spark plugs go, and there'll be pin coils or stick coils on this particular model. This one also shows you a little bit more technicalities. There's some access ports on it, and right here would be a cam sensor. The cam sensor tells the computer basically what's going on with the engine and the rotation, and helps to spray fuel at a certain pattern and time. This would be a camshaft that would be extracted off the head. You'd be removing it, and the next process to this will be putting it on V-blocks and putting a dial indicator on it and checking it out to Yamaha specs. Thank you very much for your time, and we'll see you next video.